In this next module, we want to revisit our front-end application. We have this component back in our React application for the watch list items. If you can see, we have a separate folder for front-end UI as well as a separate folder for back-end. We still need to worry about this CORS plugin here that eventually we should not have to use this. Ideally, the browser should not have to have a special plugin. Ideally, the server should resolve this type of issue. Back in our watch list component, our React application, we just had an empty fragment. Ideally, we would like to pull in the watch list from the backend server. We can take a look back at how we did this in the crypto dashboard with the fetch API, and we can do the same technique to make our watch list fetch data. Back in our watch list component, we need the use state hook as well as the use effect hook. We want to trigger the fetch API when the component mounts, just as we did in the crypto dashboard. So we need to use the use effect hook here. We also would like to track the watch list items in state. Just how we did in the crypto dashboard, we're going to use our array destructuring to pull out the watch list item and a way to set that state using the use state hook. And we're going to default this list to an empty array. We're going to define our fetch method here. And we can just console log it first just to make sure that our component is mounting correctly and test that in the browser. And ideally, we would like this use effect, this effect to fire one time. So we need to provide an empty dependency array. In that way, this hook will behave in that way. If we did have a dependency, it would watch that dependency, but we're just interested in the component did mount type of behavior. So if we go back to our browser here and we look at the dev tools and console log, ideally what we're looking for is just to see that that fetch method has been called. So in our console log, we can see that the watch items have been fetched. So this is wired up. We can use our split screen here in Visual Studio so you can actually have two panels. So you can look at the watch list component and we can refer back to our crypto dashboard and just see how we fetch the data. This is actually a pretty good technique when you're developing, so you don't have to keep switching through tabs. So we want to make this asynchronous, just like we did in the crypto dashboard. And we would like to use the fetch API and await on it. So we're going to wrap everything in a try catch. Just in case there's some type of server problem, we can catch the error and maybe show a dialog. We can console.error, the actual error message here, for debugging purposes. Inside our try block is where we're going to capture the response. And this is where we're going to wait on that fetch. And by default, we're going to be calling the get request. So take a look at how we called and invoked our watchlist API. And we're running on localhost port 3007/watchlist. That's the get request. So for development purposes, we could use this hard-coded URL to fetch. Ideally, when we go to production or if we were going to different environments, this URL would change and we would have it as an environmental variable. So once we have it fetching across the wire on port 3007, we still want to check whether or not the response is okay or not. To check that if there was an error, we could throw an exception and we could log that error to the console. Now that we throw our own exception or error, we can capture the actual error message in line with how we did it in crypto dashboard. Next up, we want the actual watch list data. So this is, remember, is the two-step process we need to do with fetch API. It's once we get the response, we need to unpack the data within a response.json. So we await on that as well. After we have the data, we can console log it before we throw it into state and see if we have any errors. I'm expecting that we're going to have a communication error here, but let's take a look. So back in our browser here, JSON.stringify the raw data, and let's take a look at this actual payload here. And it looks like the watchlist data is coming through on the browser, which is fantastic. But it's only happening because of our CORS plugin. You have to remember, if we remove that plugin and turn it off, we may get into the same communication error that we had earlier. Now that we have the data, we need to set it into state. So we're going to use that set watchlist item hook, and we're going to set the raw data. And from the front end perspective, this should fetch the data and set it. Next up in our fragment, though, we need to do the same iteration over that data set. Watch items update. It'll trigger React to re-render and re-render and redraw this JSX. So we need to make sure that when state updates, we're rendering the correct data that's available. So we're going to wrap this in an unordered list for now, and we're going to have everything output as a list item. So we're going to take our array or our list of data, and we're going to use the JS ES6 Plus map function for arrays. We're going to iterate through each item, and then we're just going to return a list item for each watch list item. So we have an unordered list, and we are dynamically filling up that list with items, watch list items. We need to make sure that we are braces to evaluate, to tell JSX and React that we need to evaluate this and whatever the watch items are, and then we can allow us to iterate through them and return back the LI fragment, which is actually a list item in HTML or JSX. So here is we're going to be outputting that little symbol, and we should have something rendering. Back in our UI, you can see we have the item.symbol. It's because we haven't evaluated what that is. So we need to put the braces around this as well, just so it tells React to evaluate what the underlying value is. So we need to make sure we're wrapping item.symbol in braces. Once we do that, we can see back in our UI that we have those codes that we have from our database. So we're going the full stack through 4 layers here. Now we want to try to turn the CORS plugin off, and we need to deal with this finally. So if we refresh this, we're going to get an error here. And if we go to the network tab, we're going to see the same problem that we seen by going externally out to the CoinMarketCap, except this time, this is trying to call across to our local host. The browser doesn't like this because it doesn't know that this is a trusted request. So you can see it's 200, it's fine, but the browser is actually stopping us here with this security issue. So we can see the watch list items without the plugin, and then when we turn it off, we get the same cross-site origin error, resource sharing error that we had before. So now this is where the server starts to shine, because we would like the server to resolve this problem. If we go back to our npm repository and we search for CORS, there'll be a trusted node middleware package for CORS that actually the Express team recommends. So this is middleware. So what that means is in between the request, we can have this CORS package that modifies the request or the response. We need to install this CORS, and it's going to enable all of the requests to be friendly to our browser. So first off, we need to make sure that we cancel our running server here, Control X, Control C. Make sure we're in the right folder, or the right project, which is backend. And we're going to run that npm install CORS. It's going to be a dependency of our backend project. Once installed, now we want to bring this npm module into our main server file here, the app.js. We can take a look at the docs here and how they use it. And it just looks like it's a module that can just be easily imported or required. So we're going to pull this in here. We're going to set a variable up for CORS, and we're going to require it. It's very easy to use now. The later packages, you just need to wire it up via middleware, via app.use. So it's very, very convenient now. You just set this up and it'll actually it'll actually work, intercept the requests and make them all. It'll basically add a header security kind of to allow all requests, so that when our browser gets a request or makes a request to the server, it will basically mark it as secure, make it friendly for the browser to not block it. In the past iterations of this project and older versions of Express, there was more configurations with all of the verbs, get, post, delete, and you had to mark the header to trust all of the requests. But right now, the current version is very easy to use. Like we said, it's just middleware. And once we set it up, we verify in our Postman that everything is still working, track our post requests and our get, and make sure that we haven't affected how the underlying Express API is working. So we'll add a new symbol here for render. This is successful. Okay, we'll go back to our delete get request here and fetch it, make sure that persisted. So we can see it's running as it had before, unaffected, which is good. So the real test now is going back to the UI and solving this problem in the UI and seeing if it's affected. So let's go back to our UI tab here. Our CORS plugin is off, and we can see the list now. So we've solved the CORS problem. This is the importance of the server. The server is dealing with the security of this application. We're not doing this in the UI. We're not doing this in the browser. The security is taken care of and a responsibility of the server. We have a secure server and a secure API. Now that we've enabled CORS, our UI can call into CORS. We can remove this plugin for the watch item. Next up, we would like to solve this problem, ideally with the coin market cap. Ideally, the coin market cap, that communication should not live in the front end. That should be in the back end.